what this does, what I'm getting ready to tell you, will protect your rig. Okay, it won't protect everything in your house, because if it comes in over the power line, it's not going to protect you. What you need there is some kind of circuit protection in your utility box, and they sell them. They're called MOVs. Different, people like Square D sells them, Siemens sells them, and what you do, you have a professional put it in the box. If you don't do it right, they can catch on fire.
Really?
Yes. So please get that for your house. Now that won't protect everything in your house from a direct hit, but it'll save some things. So now, what would you, let me just go through the presentation here. Everybody that has a remote station or a ham radio that doesn't disconnect their antennas worries about their rigs when they're gone. Okay? Wouldn't it be great that you had something that automatically disconnected your rig from the power and from the antenna, and you're not home. It does it automatically. So that's a great thing to do. Another thing is, you got to disconnect the ground. A lot of people don't realize that most rigs are taken out. And like if lightning hits close to the antenna and induces a voltage on the antenna or hits your antenna, it's going to take the direct path to ground. And I'll show you a picture in a minute, which could be through your rig. I've worked on a lot of rigs that have been hit by lightning, and guess what? Their ground wires are all burnt up. Reconnect the ground and it works. If it didn't take the traces out on the way through your rig to get to the utility ground. So that's the key, guys. You've got to, some people say, oh man, you don't want to disconnect that ground because that's what protects your radio. Not from a lightning strike. It may protect the radio from an RF burn on you, but it's not going to do it for a lightning strike because it's going to look for past the ground. And I'll show you a picture in a minute here. This right here is key. Here's a lightning strike. Say it hits your antenna. And I wish I had. Let me go ahead and stand up here. So lightning hits your antenna, it comes down. Hopefully your antenna's grounded, your tower's grounded. And guess what it's going to try to do? Here's your rig sitting in the window. It's going to try to find utility ground. Utility grounds are great ground because they go all over the neighborhood. They can disperse that energy all through the neighborhood and all the grounds in the neighborhood. So what it's going to try to do is going to try to go through your rig's ground to get to that. The key thing here is this piece of wire right here. You need to have that. And even if you have that and have your antenna not disconnected, it'll take two paths. It'll take it through your rig and through the ground undergoing. It's going to find the least path of resistance. And even, like I say, for instance, say that's 2 ohms. And that's 2 ohms, or that's 10 ohms, it's still part of that current's going to flow through your rig. So this little box right here is this. And I'll show you how to work. This thing's automatic. Right now it's actually, this is out of my house. You'll see a picture of it on the first page. That's right out of my house, and it's in automatic mode right now. I can change it to, I can manually open it and make it stay open, or I can manually close it and make it stay closed, even if lightning's in the area. It's got a 3-position switch. Open, close, and automatic.
Okay.
So you leave it in automatic, you leave your house, thunderstorm rolls up, it sees it, opens it. It disconnects your antennas and grounds. I'll show you that in a minute. And let's see what else I want to do. It's on a battery. We're going to go through all that. Anybody have any questions about that?
Yeah, I got a question. Connecting the ground rods, you should use number 6 gauge.
The bigger, the better.
The bigger the better. The book recommends, the ARL book recommends 6 or
4. I think I said 4 or 6.
Okay.
No, I don't have it in there. I think I have it in the words. But 4 or 6, guys, that's the worst thing you can do is if your box is in the back somewhere on one side of the house versus the other side of the house, it really makes it difficult to run that line all the way around. And most people skip it. And what's going to happen, an induced voltage or a direct hit is going to try to go through your rig to find that utility ground. And of course, everything connected to your utility, which is the 110 volts in your house, is going to get blown too.
Yeah.
So it doesn't matter. So that's the key. You've got to disconnect the rig. The safest place for a rig is it's unplugged and it's sitting on the floor, you know, several feet from anything. And by the way, these boxes can be made as long as you want. This is 6-inch separation, which will take care of 500,000 volts. And if you have a direct hit and you got a good ground going to your thing, you won't develop 500,000 volts across your rig or across this air gap. I've done all the math. You won't get it, even at a 500,000 volt strike with 50 amps going, 50,000 amps going through. You won't get that kind of voltage differential. So that's the key. The safest place for a rig is unplugged antenna and off to power. And this little box does both. It has an output that actually sends a Wi-Fi signal to a disconnect, disconnects everything. So that, and I'll go over that in a minute. So how do you disconnect automatically? Ever seen those little plug-ins? I want to let this thing run out the whole way here. I'll let this one run out and you'll see what it looks like. And they just slip on, and boy, they're tough to get on and off. And you say, well, how do you do 4? This thing will handle 4 antennas. So yeah, there it is right there. So you got 4 antennas that can go through there. Many people, not too many people have more than 4 antennas. Most people have 1, 2, 3. So you got 4. And what it does, it drives it in, connects it when there's no lightning in the area. And I've got mine set. You can set it any range you want. I got mine set for 10 miles. Okay? If lightning comes in with 10 miles, it opens it up and sends me an email. Okay, a text message. It says, you got lightning. Rig is open.
You've got lightning.
But let me back up a little bit. So, how do you do it? 259s, well, if people don't like those, well, guess what? I have not seen an issue. I've been using this thing for over a year, and some of the previous versions, it's 2 years now, running 1,500 watts to it and haven't seen a problem with SWR. No arcing, no nothing. Now, what you don't want to do is open those little things up so where it's not making good contact, because it uses resistance, conduction, you know, across the silver contacts. And if you got good contactors, they won't corrode. You know, if you get the silver plated ones, it'll scrape off any oxidation as it goes in and out. And it really does help, get it out. So let me show you a little bit more. So the thing here is safest you can be for your rig is to have it disconnected from ground and antennas.
Okay, so Dave, it's using those like a compression.
Yeah, I didn't bring one because I already used all of them up there.
Okay.
I used all of them in the thing. But
Yeah.
I will open this up. I mean, in fact, while it's doing that, I'm gonna let this one open. This is one I just started building.
Yep.
Let me take the power from here and put it to here. And I want to open it. It's opening now. You'll hear it popping. It's all the way closed. You want to come up here and look at it. It's actually, oh, well, I can't do it.
Getting shot.
But you can hear it coming out. It's actually turning a little drive screw and pushing that thing out. And you'll see in a minute, it'll stop and then I'll bypass it. So it'll
Disconnecting it?
it's disconnected now. It takes two minutes to go all the way out, but immediately after about 5 seconds, it's already disconnected.
I see it. It's going, it's moving. Yep.
And you'll see it, and it'll come out, and it's got a little magnetic sensor that tells me I'm all the way out. So now I got the antenna separated from the electronics too. Even this electronics is separated from the antennas. Let's see if it should stop when it's about that far out. If you look real top, you see the little magnetic latch. It'll pop it and it'll stop. And it's got lights on the top that tells you that it's stopped.
That's the finest thread pitch.
I think I got vibration now.
As fine as what?
Thread pitch.
No, it's only 18. It's 3/8 by 18.
Let's see this way.
Cool. Pretty quiet.
Yeah.
That goes on the inside of your house or the outside?
Inside. You prefer it on the outside. But
Yeah.
You just got to be waterproof. I have not made waterproof
Yeah.
ones yet.
Okay.
So there it goes. It popped it in and it stopped. Now watch. I'm gonna bypass and let it come all the way out. I got this little thing here. It's magnetic. Oh, I gotta hold it. And I'll drive it all the way out and I'll pass this around and you can look inside.
Did you print those, Dave?
Huh?
You 3D printed those?
Yes, this is all, by the way, this is all 3D printed. It takes a little bit. It takes 2 minutes to go from in. But guys, if the lightning's within 10 miles, it's prepared. It should open before lightning gets to you. There we go.
Nice.
You take a look. Don't drop these, please, because I don't know how good this stuff printed is. I do have another model which I'm going to show you, which actually has. Here, you can pass it around together. Which has fence stock, so you don't have to print it. You only have to print certain parts of it, which makes it easy. Because those prints take a long time, like a day.
Is that like nylon or the PVC?
This stuff, fence post.
Nice.
It's made the same size. Let me pass this around here. You can pass this around with it.
All right.
That goes in and out. Same size. And of course, I got an end cap. You can pass those around too. That goes. So that's the 3 parts.
Okay.
See?
I see it.
Yeah, there you go.
The black one's hard to see. But anyhow, that actually it pulls apart. It's just screwed together, and it's an old printed circuit board. I got some pictures later.
Hands on.
Here we go. This is the printed circuit board which handles the relay for the motor, and you plug your Pi into it. So that it runs on a Raspberry Pi computer, Pi 0. We got some pictures here. I'll show you a little later on.
Should be on an apple pie.
Sorry, Apple Pie won't run this thing.
Pumpkin pie this season.
Yeah.
Okay, let's move on a little bit. So that's the mechanism that I'm passing around that you're seeing. This is a real one. It's got a Raspberry Pi in it, and it's connected to the internet. In a minute, I'll show you. What it shows you is, if you dial it up on your Google, it'll show you what I have, that I can see everything. So here's my design requirements. 1500 watts, we proved it, no problem. To those push-on connectors. That's if you don't go and loosen them up, so where they don't make contact. And you can put the end cap on one of them. If you got the end cap passed around, it actually fits on one end.
Oh.
There's another one. I don't think I got a black end yet. There's an end cap, put it on there. Just gotta be careful on the other side.
Oh, okay.
Oh, you got
That's
2
what
of them
stops
now.
it. Yeah. I'll be passing them around. Okay, so the end cap goes over that square so that sits flush in the back.
Right.
Okay.
It's tight fit.
So the fence post is the outer shell, right?
Bingo.
That's what you're using, and then the interiors you made by the 3D.
Right, and I also made an outer, this one that I passed around has an outer shell that I printed. Same dimension.
That's cool.
Yep.
Okay, so anyhow, I designed it to be fail-safe. If you have that switch in the auto mode, what'll happen is, if any lightning comes within 10 miles, or whatever you set it at, whatever you set the program at, it will trigger it and it'll open it up. And lightning has got to be out of that diameter. It's a circle, a radius around your, it's 10-mile radius around your GPS point, which you program your GPS point in there. And if lightning comes within that radius, it opens it. If it doesn't see lightning for 20 minutes or whatever time you want, it will close it automatically. So if you got a remote station, it'll tell you. And also it has an output on the back with one of the phono jacks that tells your rig not to transmit. It has a PTT output that says inhibit the transmit. So if you happen to have the antenna open and you're remote and you didn't get a text and your phone wasn't with you, it won't let you destroy your transmitter. Yes, sir.
Question. What happens if the power goes out?
Power goes out, it automatically opens. It automatically opens because I got that battery. That's what that battery's for. Okay? It automatically opens. So that's in there too. So if you look there, it's fail-safe. If thunderstorms in the air, if you lose internet, it automatically opens. In other words, where it's sensing the lightning coming from, if you lose that, it'll automatically open. If you lose power, it automatically opens. Yeah, if you lose house power, it's right there. So that's what that little battery that I have underneath that other one there that you see is for. Might pass this. This is what the electronics goes in. It goes on the top.
Oh, yeah. So there's a little pie in there, I think.
Yeah, well, it's got that little board with the pie. Did I pass that board around? I think I did.
Yeah, you did.
So, I mean, and they stack on top of each other inside that little spot with 2 limit switches.
Yeah, that's what goes in.
There's a limit switch in there that actually opens up, and you see where the limit switches are. Thank you. Yeah, those things are, if you start stacking them, they will.
Cut it off.
So as you can see, I've got a few made. I don't have all the, but right now, guys, the biggest problem is Pi Zeros. You can't get one.
Yeah.
And that's because of the chip shortage. When I started making these, they were $15. Now if you go try to buy a Pi Zero, somebody will scalp you on eBay for $150.
Yep.
I mean, it's that. But my next design, version 5, this is version 4, will use just a ESP8266. I don't know if y'all know what that is.
Yeah.
You know the little Wi-Fi switches
Bluetooth. Yep.
that you can turn off and on with Alexa or Echo or whatever you want?
Yep.
That, it'll actually, I've got one of the boards that I passed around. I made one with one of those on it. I've already got it. It's got to be in testing. I got to do the programming.
Wow.
So now you don't need a Pi. You have to run this software, though, on a computer that will be on all the time. It could be your desktop. It could be another Raspberry Pi 4, 3, whatever. But you got to have it connected to that. Something to tell that Wi-Fi switch to come in, or, turn on or turn off. And Alexa now, they're starting lightning apps for it. So eventually they'll have that on Alexa, so you can ask it to turn your thing off and on. So it matters, as long as you got your Alexa on, or your Echo, or whatever it is, it'll do it. So that's the next version. I just got to get the software. I'm trying to get my software guys to help me out, but they don't want to help me out. All right, I'm getting ahead of myself. Anyhow, just to go on some of this is the part. And by the way, I'm going to make this stuff available on the W5SLA.net, so you'll be able to get this presentation. Okay. And you can see there's another print right there coming up. That came right off the printer. That's the box, the outer box as I call it, which you saw there. It can be made out of the fence posts. The only problem with that is now you got to go drill it. And drilling those holes in the right spot, I had to print me a drill guide. I printed a drill guide that I can put this in. Not press this in, to drill all my holes.
Jig, yeah.
Jig, yeah.
Yeah.
Oh, I see, I see.
So once you have the holes, you can do the slots and all that stuff, but you got to have those in the right spot, or they won't match up with the end cap. So, but anyhow, and there's one of the printed ones. That's the printed outer shell. That's the model that's on my computer, and that's the actual printed. And here's the box, and of course the limit switch stuff that goes on the inside of the box. And I can print my call or anybody's call on there. I'm not selling these, by the way, yet. It's just too much work. But if you're interested, I will help people out. And of course, here's the whole kit. You can see there's the board.
I see, okay, okay.
It doesn't have a Raspberry Pi because I don't have any more, because I'm not going to pay $150 for a Raspberry Pi. Not yet. And then, of course, here's how it all goes together. Shows you it all just comes together.
Somebody's an engineer.
And I got to update the parts list. It used to be about $100 in parts. Okay.
Minus the battery.
Huh?
Minus the battery.
That included a battery. I think so. And of course, here's the assembly motor, and that's a new coupler that I got to put in that one. And it works great. All it is a 3/8 to 1/4 inch compression coupler. and it cranks down on that. Listen, people say, does that little motor have that much power? I'll show you a picture in a minute how much power it's got when the fail-safe circuits didn't work because I had them wrong. I had them bypassed. Okay, so that's that. Here's another picture of the, tells you how many quantity screws you need, and you can see a picture of it just by the internal workings itself. That's what that looks like. And that's it together. And just some more pictures. Oh, the ground. There's the grounds. You see the grounds there?
Yeah. Those little
And it's
studs.
just, it's couplers that come and they stab. So you can have your own ground. I don't ground my rig, but I do have the capability to do that.
Like banana plugs? the
And
ones
it's
that-
banana plugs.
Yeah, okay.
Silver plated, I mean gold plated banana plugs.
Nice.
And of course I had this, there's another, well, I don't have a good picture. You can see where I actually soldered that on there, and it goes into those little slots that you see here, one on each side.
Nice.
Okay, and it's brass rods. So, and there's the schematic just for the motor control board. And the Raspberry Pi actually connects with 3 connections right there. That's where the Raspberry Pi plugs into the board itself, into the little control board here. It has the relay on there that drives the motor, and also the voltage protector for, I mean, the fuse that automatically opens if the current to the motor gets too high.
Hmm. Yeah.
And there's the board itself, and there's that little fuse, you can see it there, it's a little fuse, a PTC as they call them. If the current goes over 3 amps, it shuts you down until you reset the voltage coming in. And that's the design of the board, that's the picture of the board.
You had these made with someone?
Yeah, I had them made in China, because it only cost me.
They use their software, I guess, to render that?
Yes,
Okay,
I did.
okay.
I rendered it and sent it to them, and you can get 5 boards for $2, but then they hit you on shipping, it comes about to be $25.
Yeah. Nice.
So here's the future hardware, I mentioned this earlier. If we could find somebody in the ham community that does injection molding, that would eliminate a lot of time printing these out. So if somebody knows somebody, that's what I'm looking for, that has injection molding, that can make these things, about $1,000, I'd go into sale for these things.
MFJ, I think, huh?
I don't know who has it, but it's expensive to set up
Yeah.
molds and stuff like that. But if there's somebody that knows somebody's got an in, we could probably get a few test ones done, we could do it. I redesigned it already to use the vinyl fence post, as you see that. And of course, you drill your holes, and it's amazing how accurate that 3D printer is, man. It's right on the money. And these fence posts are good accurate too. I'm surprised they put them through an extruder, so they're all the same size. And let's see, an ESP at I think it's 8266. I missed the 2 in there. But that way it can be connected to an Echo or Alexa, something like that, which you can completely eliminate the computer inside there. It'll all be on that board, that one board. And the software, how many are familiar with Node-RED? Got one? Okay. It's a Linux type thing that you program with blocks, and I'll show you a picture of it in a minute. And you just tell the blocks what you want it to do, and you connect them together. And basically, we connect to a place that has thunderstorms, and I'll show you that in a minute. It's not weather anymore. It's not the one on here, what they call open weather map. It's something called Blitzberg, and I'll show you that in a second when we get to the real thing.
Blitzer Tom.
Yeah.
Blitzer tug, yeah.
And
And continued, if you open up a Gmail account, or if you got your own account, you don't mind all the lightning alerts coming through.
Yeah.
Because let's put it this way, in August, you'll get 2 or 4 or 5 openings a day when this thing's protecting, yeah, because you've got lightning all over the place. Thunderstorms in the afternoon, they pop up every afternoon. I finally disabled mine because it kept on lying. I said, I know you're working, I don't need you anymore. And of course, I've got it programmed, so if the software is turned off or you lose internet, it automatically disconnects. That's in the program too. So.
Oh, so it's checking for connectivity.
Oh yeah.
And far as okay,
If you lose
fail
power,
safe.
or
Okay.
you lose connectivity, she's open it unless you have that switch in manual mode.
Nice.
So if you have it in auto mode, it's going to stay. I mean, it'll open. So, and the reason why I'm going fast, guys, because we don't have a lot of time. But yes, sir.
If you have it in manual mode, do you still get the emails or like a warning or
Yes.
anything? You still get the warning?
Yeah, because the manual mode just bypasses all the electronics. Yeah, it'll still get the emails and stuff like. It'll still try to open it, but it won't be able to because it's bypassed.
You're gonna show them the logic. Yeah, the logic is still running of that Node-RED software.
Yeah, I'll show you in just a second. If you lose house power, it opens up, checks if the internet's online. Once there's no lightning within 10 miles, it'll automatically close it for you. And it's got to be for 20 minutes at least. Or it's programmable. If you want it for an hour, you can program it for an hour. If you want it for 20 miles away, you can program it for that too. And that's the logic for the to make it work right there. It's hard to see, but what we do is, if you look here, I set up to go to this website right there at the top, and I set it up to go get the data, which is the first blue box. And it goes over, it gets the data. Once it gets the data here on the second box down, let me get up to the picture so you can see. Once it gets the data, it comes into this function block, which I'll show you in a minute. And basically that's what tells you where your GPS is, where your house is. It tells you what to look for, how many miles out. And then it passes that data as in kilometers. So for us in the US, we convert it, touchscreen. We convert it to miles. There it is down there. We got two functions, I'll show you both those. It converts it to miles. Then it sends over here, basically a decision block, is the lightning within 10 miles because it sends it out. If it is, it comes over here, lightning strikes in the area, do not connect for 20 minutes, and then it goes over to here, which goes to a page that actually disconnects, right here. It actually comes to the Raspberry Pi, which tells it to go turn pin 7 on, to go open it up. I know that I'm going over this pretty quick, but
Yeah.
but it just the explanation might get it. And of course, the bottom part is for the emails. And if you want to connect, is online. This one, keep trying to make that one can connect directly to the Raspberry Pi and open up that relay. I don't have mine connected right now because my internet's been going in and out. So. That is where you connect it up to the top line there. And of course for the dashboard, which I'm going to show you in a minute, this is functions for the dashboard, which lets you go see what the thing's doing if you're remote. So we're going to go to the dashboard next. So I'm going to bring open the browser, and there's the browser. We actually have lightning at 574 miles away right now.
Nice.
Okay, and of course, I've got this scale from 0 to 50 because I'm only caring if it's in 50 miles.
Right.
So it's going to stay pegged until it gets below 50 miles. And if you also notice, right here, the lightning distance, right across. On a big screen, they put them right across each other, but on this little bitty Pi, it just switches them down. You can see lightning distance in mile. You can see it just now starting up. And it shows you that for the past 2 hours. It shows you the CPU PP load, the temperature of the CPU, the memory used, and when the antenna has been turned off and on. So you can go back and look if it was turned off and on for up to a week. And you saw I still got my dashboards here for the CPS, the CPU load. It usually runs around 50%. When the lightning gets really heavy, because it's analyzing a lot of data, it may get up to 90%, which turns this thing red. But it never goes over 100% with a Raspberry Pi Zero.
What software is this?
That's Node-RED.
That's Node-RED. Okay.
Node-RED. And you can see the memory used, CPO, pretty cool in here, 38 degrees, you know, Celsius is not too hot for a Raspberry Pi. Very cool. Now, watch the real thing here. I got my cables on there. I said, I want to test it. You hear it?
Barely.
No.
You put it in.
Oh, dummy. Where's my battery? I got to plug the battery back in. I pulled the battery off, so let me go back to simulate lightning in the air. It's not in the area. And then plug my battery back in. And I'm in auto. Okay, very good. Now watch. Hear it? It's quiet. It's opening. I'll let it go all the way open. And you see it gave you a warning, because what I did, I said lightning's within 10 miles. I injected into the software to say it's within 10 miles. So it's coming back out. And of course you got to leave room for your cable.
Yeah.
Because if it's stiff, it'll push that box into a window and it'll go somewhere. It'll even make it go up. Oh, it's got that much strength. I'm going to show you something that happened when I didn't have the safeguards in place.
I'm sitting here trying to pluck a bug off of my screen. There's something turning on it, right? It's turning, the center's turning.
Yeah, it's kind of.
Like, what's
I got a
swinging?
little. Y'all can't see it, but I got a little stripe on the
Yeah.
nylon tube. Okay. It's going around, so you can tell it's
I'm
moving.
like, wait, what is that bug on my screen?
And now it's gone in and it's starting to come out. It'll automatically turn off.
Neat.
So.
Nothing's gonna arc across that gap. That's what you were saying earlier.
If you've got your grounding right,
Okay.
there should be no way it should develop enough energy. If your ground between your antenna ground and utility ground
Yeah.
is good, and guys, you realize you just can't put a clamp on it. You really need to do that thermite stuff, which it makes it go onto the copper ground. Because what happens when you do just those little clamps, they corrode.
Yeah.
Because they're out in the weather. And guess what? That's high resistance. It's like not having a ground. Think about that. And see, it's got the red light came on, it's all the way out. And I'm going to send it back in because I'm going to say simulate lightning not in the area, which I picked 1,000 miles as a thing. So you put 1,000 miles and it's going back in. Now you will hear it when it goes back and it tries to mesh. You'll hear it go.
Yeah.
It's in because it's
Torque it.
those things are hard to get. We tried it with the very first one I made. I made a prototype, and you can't get it apart. You really got to push it.
The clutch.
So anyhow, it'll go in a minute. And also on this, while it's going in, I'll show you something neat. Lightning map brings it up, and where it said lightning is around 500 miles, there it is down there in the lower left.
Is that storm that's down there?
No, you want to see the storm? It's right down here.
Yeah.
So there you got this lightning here, which is about 500 miles, and there's lightning way over there. It wouldn't pick that up because I basically set, I only monitor if it's within 1,000 miles. And I only care if it's within 50 miles, and then I turn it on if it's within 10 miles. So that's the,
That's an awesome network.
Fix everything.
you'll hear it in a minute. It's hard to hear, but you'll hear it more. Yeah, it's got to go in a ways.
Oh, okay.
Got some lightning down there in Tijuana.
Those linear actuators have
Oh, it does. You will see in a minute because I'll show you. Here, it popped. It just hit the first one. It's struggling a little bit. And it hit the limit switch. So it's there.
Nice.
So that's that. Let me show you see if we got any more. Oh, did I erase all the ones after this?
I didn't do
Oh
it.
no, I'm on the different one. Let me get off of that. So that's the program. That's the screen I just showed you. And of course, when there's no those lightning miles you said, it says out of range. And that's what you see on the screen here. Software of the future, incorporated a Wi-Fi switch that you can control with Alexa, whatever. And that should take care of that. Backup history. I went through many of them. I went through a prototype, and you saw my prototypes.
Yep.
It's just, I'm not gonna go through all of that.
He's a mad
That-
scientist, y'all.
You can see some of the boards. That used to be my old board. I did it on perf board. And there it is right there wired up. So you can see how the limit switches are in there. And of course, there's the schematic for it. That's version 2. Version 3, I went to the board, and there's some of the parts, the major parts. And let's see. Oh, I did not put that picture in there. Oh, man. I think I got it though on my pictures. So hold on. Where did I take that picture? So back. Here we go. Here we go.
Oh,
It pulled that whole thing through.
it's got some torque.
It got some torque, and you can see it there. I think I got a picture. That's what it pulled out of the plastic. So that flat just tore it up, man. And it wasn't no stopping it.
No limit.
Because what I had, I didn't have the protection circuit in there, and I just put a solder bridge across it, so it let it take as much current as it needed to drive that gearbox, and it just pulled it right out. So that's what you don't want. So it's very interesting. Let's see if there's any other pictures in there. And of course, that's just a picture of the box that you see here. And let me see. Kitties, and there's some of the recent pictures I took with the new coupling, which actually makes it a lot easier. You notice with the old coupling, I had to put glue to hold it in there because it would strip it. So I had to put some of that JB Weld stuff, and that kept it from stripping. In fact, that one's got the JB Weld. The new one here has the couplings that compress. It works a lot better. So, all right, I finished in 40 minutes. Are there any questions?
I take it you're protecting something with this?
Oh, I'm protecting a Flex 6600. So it's plus the amplifier goes along with it, which is $7 grand. So 6 and 7 grand, 13 grand. Protecting 13 grand worth of equipment with this. So
Worth it.
it's worth it. But anyhow, that's what I done. I mean, I might have been a little bit too quick and too over everybody's head, but it is. I like it. I don't have to worry about my rig anymore because it's going to be taken care of. Now, some other people may be in here, as I was going over earlier. They're not necessarily worried about their rig, but they're worried about their equipment in their house, so forth and so on. Cable TV, your TVs, everything. If you get a direct strike on your house, guys, and you don't have something that disconnects your whatever, the appliance from the circuit, it's going to fry them. The only thing to help you protect on something like that is to go with the circuit protection in the utility box. And by all means, get one rated more than what your box is rated, because you want it to really protect. And it's not going to protect everything. It'll protect a lot of things, but there's some sensitive stuff that will still get the induced voltage. And that's another thing people say. You don't have to be hit by the lightning. Lightning can hit a couple hundred yards away and still wipe out stuff in your house. Your rigs especially, because they got sensitive front ends. Even if you have those lightning protectors that go on the coax, that limits it to like 1,000 volts. Can you imagine putting 1,000 volts of static right into your receiver? Yeah, it helps it. What it does, it keeps the voltage between the, and some of them go down to like 300, but you got to be careful because your RF, if you run an current, watts, you're going to go up to 300 something volts easily if you're running 1,500 watts into 50 ohm dummy load. 50 ohm antenna. So they're usually rated above that, 500 to 1,000 volts. Then they're nothing more than a little air gap or neon or tube gap in there that has a tube, and it'll keep the lightning from getting too far out the way. Too high a voltage and cause a problem.
Remember
See
to
my
keep
face.
your homeowner's insurance up.
And maybe, they may not cover ham radio.
No, it'll cover lightning damage to the rest of the house.
That's right.
An act of God.
That's right.
But you can get ARRL insurance. Now,
Yeah.
maybe this picture makes a little more sense now that we went through that, and that's where mine sits in my house, right up against the window. And, yeah, this is only to protect your rigs. And as I go back, get the MOVs that go into your utility box that will limit the voltage between the ground and your 110 volts. See, what happens if lightning strikes near your house, it could raise the whole potential of the ground several thousand volts, maybe 50,000 volts. But your whole house comes up and down at the same time. And what you're trying to do is regulate your 110 to the ground voltage, because that's what your equipment sees in the house. So, and another thing is, if you got coiled wires in the house, just the current hitting a tree or something outside your house creates a magnetic field which will couple to the house wiring and then send that, it's just like a transformer.
Transformer, yeah.
It will send all that voltage into your equipment, into your house. So, if you want to be safe, unplug everything. And of course, if it doesn't have a long wire, it can't get voltage induced into it. So, if you unplug it and you got an extension cord that's 100 feet long, even though the extension cord is not plugged in, it could induce voltage into that 100-foot extension cord, just like a transformer, and turn it into your rig. So that's the key, guys. Induce voltage and direct strikes. I think this system will take a direct strike. I really do. If you do all the stuff, make sure you bond the grounds and so forth. Now, everything in your antenna and inside your little ground protectors that may be in your outside box, be fried, because it's in the path to ground.
Let's
Won't
not,
save the antenna.
let's not test this theory.
But, no, you don't want to test it. But I have faith that because of the outside ground and stuff, that I won't get enough potential across that gap to cause a problem. Now, if you don't trust that gap and you do your own math, you can take a fence post and get it up to 5 feet long. 5 feet should be plenty enough. If you can find a rod that long, you can buy the rods at 4 feet, so maybe 4 feet's the limit. So, I don't know if y'all saw, that's the key to it, is this
Nylon.
Just had the piece cut off. That's what drives it in and out. Very high insulation per centimeter. Very high. Electricity will not, and if that's what they do, the high voltage lines have those types of stuff. So you can pass it around the back. So, and that's the thread right there you were talking about, Mike, on that particular thing. So that's that's the whole principle of the thing. It's just now some people I've seen on the internet, they go buy some of that starboard, which makes the nylon type stuff, and they put these actuators on it, but they forget that if you have any metal, if they use a metal actuator, it's going to go right through that to get to your rig. It's got to be completely isolated, and they don't realize that. I've seen some of the ones that says, what about that spot right there? You did nice. They mounted it on something that was mounted to metal. So it'll jump to that, then jump back. So you got to make sure. In fact, this picture has a flaw in it. How many people see it?
Yeah, it's sitting on metal.
It's sitting next to that metal window.
Yeah. Oh, that's metal,
Jump.
the frame? Okay.
So what'll happen, and what I got to do is I got to get some better insulation. Here's your inputs. It'll jump from here to here, come over there to the back side, and jump back.
It'll find a way, huh?
It will find a way. So I got to put that. I'm going to put it up in my attic, so where I don't have anything within 6 feet away. So that's the only problem with this one. This one actually had a flaw. I was waiting for somebody to say something. I didn't see it.
Oh, no.
So that's the thing you got to watch, because air gap. How much voltage do you think it takes to go across an inch of air gap? 1,000? 75,000 volts. It's 3,000 volts per millimeter, I think. Yeah, so you take 25 millimeters, which is in an inch, it's about 7,500 to 76 1,000 volts. But lightning goes up into millions,
Yeah.
so it will break down an air gap very quickly. This is way, way up there. It's 10 to the 7 or 8 or something, so it's not going to travel down this as much. It'll find the air gap before it does this, goes through this. So that's what you got to realize. So, got a lot of this thing here.
Neato.
Got to see my face. Any other questions?
I have one question. I have that same pass-through that you had, the MFJ,
Mm-hmm.
maybe a different model, but I had the, came with the SO239s and I got rid of them because I had the PL239s and it was really hard to, there was like a gap on the end of it trying to connect the cable. Did you do that on yours or those SO239s?
Those are SO230.
239s? Okay. Using the two SO239 ends?
No. The one on the cable, on the coax is 259s, and they go right into the SO239s on the.
I had such a hard time. I replaced
They're
like
cheap.
4 of them and it's been great.
Yeah, they sell cheap, they buy the
Because
cheapest
it was
ones
like a
they can.
huge gap at the beginning, and I just screwed it on. I don't know why it was so big.
The threads are not usually right. I had to rework some of mine, or work them
Yeah.
in,
Oh,
once you
okay.
get them.
You must have got a good set
Yeah.
then. Okay, I was just curious.
Yeah.
Yeah.
But anyhow, guys, that's lightning as I see it. So if
Hopefully you never see it.
hopefully I'll never see it. Well, I've been hit close, and this has been there. It was within several hundred feet,
Whoa.
but it was open, and it didn't get any induced into my house. It took out something else in the house, but it didn't take out the rig, which is good. So I do believe this is the best way to go. Now, as I showed you there, that's the problem of mine. I got to move that to the attic where there's nothing around but at least 3 feet. That's what you want. Okay? Or at least 6 inches. I mean, that's not 6 inches. That's the budget. And if you really don't trust 6 inches on the air gap, you go out to 5 feet with these metal posts. But of course, you have to worry about the length of this. This was a 2-foot section that I cut off for the stuff that goes in there. So, all right.
Cool.
All right, thank you.
All right, Dave.
Oh, by the way, please check on the board in case your name was called for one of the hours.